In this video, we are going to be looking at nitrogen compounds. Just to introduce you to the topic, we'll look at nitrogen and we'll cover some properties of nitrogen. Now, these are some things you need to know about nitrogen. The first one, nitrogen is in group 15 of the periodic table. So you may say group 5 or group 15, and what that means is that it has 5 electrons in its outermost shell. I'm going to show you the configuration in a bit. Now the second thing to take note of is that it is a non-metal. Now it is essential to know that nitrogen make up about 78% of the Earth's atmosphere. The fourth thing to know is that nitrogen exists as a diatomic molecule. Now, the fifth thing to take note of is that nitrogen needs to gain 3 electrons in order to have a noble gas configuration or to fulfill the octet rule. Now, for this reason, they form triple covalent bonds. So you have one nitrogen triply bonded to another nitrogen. So it exists as N2 molecule. So in drawing the structure of nitrogen, the first shell has 2 electrons, and the second shell has 5 electrons. Alright, so let's write a configuration. So we have 1s2, 2s2, and then 2p3. So you see the first principal quantum number 1 with 2 electrons, and the second shell 2s and 2p have a total of 5 electrons. Now you can be asked to show the dots and cross diagram for the bonding between 2 nitrogen atoms. So to do that, I'm going to draw my valenced shell. So this is a valenced shell, and I have nitrogen in there. Now I need to indicate the 5 valence electrons. So 1, 2, 3, 4, and 5. Now I have the second nitrogen atom. So again, the valenced shell. And this time I'm going to use cross to represent the electrons. So 5 electrons, 1, 2, 3, 4, and 5. So this combines and give me 2 shells intercepting each other. So in the intercept, I need to indicate the triple bond. So I have 3 dots and 3 cross, indicating the triple bond. Now on each nitrogen atom, I have 2 electrons left. So 2 on this, and then 2 on this. So this is a dot and cross diagram for nitrogen gas N2. Now you need to remember that N2, which is triple bond, triple bonds consist of 1 sigma bond. Now you need to remember that we form the pi bond by sideways overlap of the p orbitals, which again you could be asked to draw that. So in order to do that, you draw 2p. So this is a pi bond. The p subshell is like a dumbbell, so you draw the first one, then you draw the second one sideways overlapping with the first one. So this results in a pi bond. And for the sigma bond, we form sigma bond when 2 s orbitals overlap, or you have 2 p orbitals overlapping head on. Okay, so for sigma bond, you have 2 p orbitals overlapping head on, or you can have 2 s orbitals overlapping. So this is a sigma bond, this is a pi bond. Now, one last thing you need to know is that the N2, which is N triple bond N, is a very strong bond. Now, this bond energy is around 1000 kilojoules per mole, which is a lot of energy. And for that reason, nitrogen gas is unreactive. So if the air could be reactive, nitrogen gas is the one nullifying it. So nitrogen, the triple bond is shorter and stronger and very difficult to break. So one interesting thing that happens in the atmosphere is when you have lightning catalyzing the reaction of nitrogen with oxygen to form nitrogen oxides. Now, the lightning provides the activation energy for the bonds to break. So in the next video, we're going to be looking at how we form nitrogen oxide compounds, which is a natural source of nitrogen oxide, and we'll look at the reactions involved.